Young little minds, welcome to another episode of All Fours e-learning program. I am DNR, your physics lecturer. This is physics session number 12. Now in this session we will take up some illustrations of parallelogram law of vectors. So today's topic is some problems or numericals on parallelogram law of vectors. Parallelogram law of vectors, right? So we will take up the illustration. So before going that, let's have a recall of what we have studied, right? Let us have the recall of the things which are useful to understand today's topic. So I was telling you, physics, subject of measurement. When you measure, you get a quantity. Well, physical quantities are of two types, scalars, vectors. Scalars are mere numbers, no direction. Vectors have both magnitude, direction, and they obey the laws of vectors. Then different types of vectors have given, right? Different types, different. We have talked about the representation of vector, different types of vectors, resolution of vectors, rectangular components, then position vector, then addition of vectors. You know, addition of vector is of two types: graphical method, analytical method. Graphical method is by pictorial representation I find the resultant. Triangle law, polygon law are the graphical methods of finding the resultant of two vectors. For two vectors it is triangle law, for polygon law for any number of vectors. The analytical method of finding the resultant vector is parallelogram law of vectors, the mathematical method. So according to parallelogram law, if two similar vectors, you know, when you are adding vectors, the vectors must be of same physical quantity. They should have same units. So two similar vectors. If two similar vectors are represented as two adjacent sides of a parallelogram, right? Starting from same point, co-initial, they must be co-initial vectors. Then at an angle theta, suppose, then the diagonal passing through the point of intersection of vector represents the resultant vector. So if two vectors are represented as two adjacent sides of a parallelogram, then in magnitude and direction, then the diagonal passing through the point of intersection represents the result vector in magnitude and direction, right? And the magnitude of the resultant mod r, it is under root of a square plus b square plus 2ab cos theta, where small a small b are the magnitudes of this vector. Mod a bar is a, mod b bar is p, then it is like this. The angle made by the resultant with the a bar, so it's alpha, so tan alpha is b sin theta by a plus b cos theta. This is the resultant of two vectors, right? The magnitude of the resultant and the direction of the resultant. Later we have taken the cases also, if two vectors in same direction, then the resultant is maximum. When a and b are in same direction, theta 0, the resultant is maximum. Theta 180, opposite direction, resultant is minimum. Maximum resultant is a plus b, minimum resultant is a minus b. If two vectors are perpendicular, then the perpendicular resultant is by Pythagoras theorem root of a square plus b square. Perpendicular resultant. And we have taken a very important case in the previous session. If two vectors of same magnitude, two similar vectors of same magnitude, a bar, mod a is p and mod b is also p at an angle theta, very important case. Then the resultant, which is given by the diagonal, mod r is 2p cos theta by 2. Now this is the resultant. The resultant is given by the diagonal. For two vectors of same magnitude, the resultant is 2p cos theta by 2, the magnitude of the resultant. And this resultant is the angular bisector. So resultant is theta. The magnitude is 2p cos theta by 2 and the direction, the resultant will be the angular bisector of two vectors. So the angle is theta by 2 with this, right? And even in this, if two vectors are in same direction, equal vectors, the resultant is 2p. Opposite, when two vectors like this, two same magnitude opposite, they are negative vectors, the resultant is null vectors here. If they are perpendicular, the resultant is root 2p. If they are at 60 degrees, root 3p. 120, it is p. We have taken all the cases, right? So for different this thing. And we have even dealt with a very important question which has appeared in many of the entrance examinations, and you know, it can even appear again later also in future also, there is a very possibility that question can appear. The question is, two vectors of same magnitude P have a resultant whose magnitude is same P. Then what is the angle between vectors? So the vectors are magnitude same PP and the resultant is also P. Then what is the angle? The angle is addition resultant, please. Then the angle is 120 degrees. Very important question. This is asked like this, right? So that way you find the resultant. Let us take up some numericals based on this. Thing there. Okay. Now first question. The question says like this. Two vectors of magnitude 5 Newton and 12 Newton are acting on a body. Two forces, let's suppose. Two forces of magnitude 5 Newton, 12 Newton are acting on a body. Then the resultant magnitude for different angles. Suppose if theta is equal to 0. So on the body there are two forces. 5 Newton and 12 Newton both are acting on the body of mass m, let's suppose. Then the resultant is, so the resultant force is equal to magnitude of the resultant. You know, when the vectors are in same direction, theta 0, we got maximum resultant. So the resultant is maximum. It is 5 plus 12, answer 17 Newton. So suppose in this one, if he is asking to find out the acceleration, let the mass be something like 2 kg. Then what is the acceleration? So from this, you know, F is equal to ma, right? So whenever I write just alphabets like this, I mean I am taking the scalar values, magnitudes only. When I put a bar, I mean it's a vector. So please remember. So the acceleration is equal to force by mass. So the resultant force is 17, the mass is 2, answer is 8.5 meter per second square. Same thing. If the vectors are at 180 degrees, if they are acting on opposite direction, then the resultant on the same body of mass 2 kg. Well, 12 Newton is acting like this, suppose, and 5 Newton is acting in this direction, the angle is 180 degrees. They are in opposite direction. What is the acceleration, suppose? Now let's find the resultant force. You know, resultant force when they are in opposite direction. When two vectors are in same direction, same, the resultant is addition. Just simply add 5 plus 12, 17. But when they are in opposite direction, the resultant is subtraction. So the resultant force is 12 minus 7, answer 12 minus 7 is 5 Newton. Sorry, 12 minus 5 it is 5. So answer is 7 Newton. 5 and 12. Two vectors, 5 Newton, 12 Newton. So the resultant is 7 Newtons. Now the acceleration is force by mass. So it's 7 by mass is 2 kg. So answer 3.5 meter per second square. So when two vectors are in opposite direction, the resultant is like this. Third one, if theta 90 degrees, if the same forces are acting at right angle to one another on the same body. So on the same body of mass 2 kg, m is equal to 2 kg. Now 12 Newton force is acting like this, let's suppose, and 5 Newton force is acting like this. Then the resultant. One more thing. When the angle is 0, the resultant force is 17 Newton in the direction of the forces. So the resultant force is also in this direction. So the acceleration is also in this direction, towards right. Now in this case, 5 Newton is towards left, 12 Newton is towards right. Then the resultant, you know, I was telling you, when two vectors are in opposite direction, the resultant vector will be in the direction of the vector of more magnitude, bigger magnitude. So 5 Newton, 12 Newton, now both are in opposite direction. 12 Newton is bigger, 12 dominates 5. So therefore, the resultant is also in the direction of 12. So resultant force is towards right, acceleration is also towards right. Now suppose if the vectors are perpendicular, theta 90, 12 Newton is like this, 5 Newton is like this. Then what is the resultant? So complete the parallelogram. Well, the resultant is like this. The resultant force, Fr. Now the resultant force, you know, when they are perpendicular, I was telling, the resultant force is given by Pythagoras theorem. So it is under root of a square plus b square. So it is 5 square plus 12 square You know 5 square is 25 and 12 square is 144. It is under root 169. Add both 169. Answer is 13 Newton. Then what is the acceleration now? Acceleration is force by mass. It's 13 by mass is 2. It is 6.5 meter per second square. Now what is the direction? This is the direction. The angle is alpha. Well, tan alpha is equal to opposite by adjacent 5 by 12. So the direction alpha is tan inverse of 5 by 12. Right? So find out the value, find the tan inverse value, you will get the angle. This way, if there are two vectors at different angle, this is the maximum resultant 17, minimum resultant is 7 and the perpendicular resultant is 30. Right? So this way you find the vector length. Sometimes he will give the same question in the reverse way. He will say like this. Two vectors when they are in same direction, the resultant is 17 Newton. Two forces. When they are in same direction, the resultant is 17. When they are in opposite direction, the resultant is 7. And when they are at right angle, the resultant is 13. He is asking to find the magnitude of the vectors. Well, from this also you can find out, you don't need this. When maximum is 17, minimum is 7, then what are the vectors? You know, maximum is a plus b, that is 17. Minimum is a minus b, that is 7. Add both. 2a is 24. So a is 12. So first vector is 12. When I subtract these two, so a plus b is 17 and a minus b is 7. Subtract minus plus minus, a get cancelled. 2b is 10, b is 5. So first direct question, he has given the vectors, find maximum minimum. Sometimes he will give you maximum minimum resultant, he will ask you to find the vectors. So maximum a plus b, minimum a minus b, you can find it. Right? So this way, the first numerical like this. The second numerical. This time, he has given you the magnitudes of the vector and the resultant magnitude. He is asking to find the angle between the vectors. He says like this, the question reads, two forces 10 Newton and 10 root 2 Newton. There are two forces 10 Newton, 10 root 2 Newton. Have a resultant force of magnitude 10 Newton. Then find the angle between the vectors. Now this is the question. Now in the earlier question, he has given you the magnitudes of the vectors and the angle. Well, he is asking you to find the resultant. It was very simple. I just substituted in this and I got the answer. Well, when the vectors are in same direction, maximum, I just added a plus b. Maximum resultant. When vectors are in opposite direction, minimum a minus b. When vectors are perpendicular, then it is perpendicular resultant. It is Pythagoras theorem, root of a square plus b square. Simple. Well, sometimes he'll ask you, he'll give you the maximum minimum resultant, find the vectors. Even that also you can do. Well, he'll give you like this sometimes. Suppose the maximum resultant is r max. The minimum resultant is r min. Now he may ask you to find the perpendicular resultant. Right? So r max he has given, r min he will give you, find the perpendicular resultant. Now what you do, from r max, you know r max is a plus b, r min is a minus b. Then from these two, find a and b, substitute the perpendicular, you will get the perpendicular. We will take up this also in the later example. Okay. Now coming to this, he has given two forces 10 Newton and 10 root 2 Newton, and the resultant magnitude he has given. He is asking to find the angle between the vectors. You know, the resultant mod r is root of a square plus b square plus 2ab cos theta. So we know the resultant magnitude mod r. So let me represent just simply as r. Right? So r is equal to root of a square plus b square plus 2ab cos theta. Now in this problem, he has given you a, he has given you b, and he has given r. He is asking to find cos theta. Let us evaluate. Square on both sides. So r square is a square plus b square plus 2ab cos theta. Now taking these two things this side, r square minus a square minus b square is 2ab cos theta. So when I get these two, cos theta I can write it as r square minus a square minus b square by 2ab. This is the angle between the vectors. You know, that is the reason why this law is also called the law of cosines. You know, The cosine angle of the angle between the two vectors. The cosine of the angle between the two vectors is magnitude of r square, resultant square minus a square minus b square by 2ab. That is the reason it is termed as the law of cosines. So cos angle. Now if r is like this and this way, the cos of the angle between the vectors you can write it as r square minus a square minus b square by 2ab. So substituting in this I get the angle. So when I substitute, so the forces are F1. So first vector, let it be a bar. First force a bar. Mod a bar is 10. Mod b bar is 10 root 2. And mod resultant vector is again 10. Then what is the angle? Substitute in this. So cos theta is equal to r square minus a square minus b square by 2ab. So please substitute. Cos theta is r is 10 square, minus a is 10 square, minus b, it's 10 root 2 whole square by 2 times of a and b. So it's 10 into 10 root 2 it is. Well, this is plus 10 square, this is minus 10 square. This is 10 square, I will get 100, minus 10 square 100. These both get cancelled. So cos theta is equal to minus 10 root 2 square. 10 square is 100 into 2 by 2 into 10 into 10, 100 into root 2. So 100, root 2 cancel. So therefore cos theta is minus 1 by root 2. Now this is the angle. Now how to find out the angle from this? According to trigonometry, now the cos value is negative. According to trigonometry, first quadrant all the trigonometric functions are positive. All silver teacups. First quadrant all are positive. Second, sine and cosecant are positive. Cos negative. So cos is negative. So the angle is, the vector is in the second quadrant. So the angle is obtuse angle. Obtuse, greater than 90. So this you can rewrite as cos 180 minus theta is 1 by root 2. If cos theta is minus in sense the angle is in second quadrant. So if the angle is in second quadrant, the vectors, first vector, if the first vector is along this, the second vector is in this direction. So actual angle I want is this. Right, so let me take, to convert this to positive, you can write as cos 180 plus theta is 1 by root 2. But according to trigonometry, 1 by root 2 value for cos function is at cos 45. So 180 minus theta is 45, or 180 minus theta 45, get this 45 are there, theta is 180 minus 45, you will get it as 135 degrees or 3 pi by 4. So this way you can find out the angle between the vectors there. Okay, right? Now next question. Suppose if the maximum resultant is 31 Newton and the minimum resultant of these two is, right, it is 17 Newton. Then find the perpendicular resultant is asking. Maximum resultant of these two. R max we know it is A plus B. A plus B is 31. And minimum resultant R minimum we know it is A minus B, it is 17. Then add both. So when I add both, I get 2A as 48. A is 24 Newton. And suppose if I subtract these two, so A plus B is 31 and A minus B is 17, minus plus minus, so 2B I will get it as, this is 14, then B is equal to 7. So I get A is 24, B 7. Now he is asking to find out the perpendicular resultant. Perpendicular resultant is root of A square plus B square. So it's under root of 24 square plus 7 square. 24 square is 576, it is 49. Under root of 625, the answer is 25 Newton. So maximum resultant, minimum resultant is asked you to find the perpendicular resultant. The perpendicular resultant is directly 25. Now from this you can even evaluate the formula also. If R max, in terms of R max and R minimum, let us evaluate the formula for the perpendicular resultant. Now we know R max is A plus B, R minimum is A minus B. Now add both. So 2A is R max plus R min by 2. R max plus R min is 2A. So when I get this 2 here, A is R max plus R min by 2. Similarly, R max is A plus B, R min is A minus B, then subtract minus plus. So R max minus R min by 2 is 2B, right? B. Well, R max minus I min is 2B. I brought that 2 down. Now the perpendicular resultant of these two, it is under root of A square plus B square. So I can write it as A is R max plus I R min by 2 and this is B is R max minus R min by 2. So it is R max plus R min by 2 whole square plus R max minus R min by 2 whole square. Then so R max you can write it as under root of, well, the LCM is 2 square it is 4. So R max plus R min whole square plus R max minus R min whole square. Is it? Now so you can simplify, it is A plus B whole square, A minus B whole square. Now A plus B whole square, A square plus B square plus 2AB. A minus B, it is A square plus B square minus 2AB. So this comes out to be under root of, this is R max square plus R min square plus 2 R max and R min. Well, plus of here R max square plus R min square minus 2 R max R min by 4. Well, if I take the bracket out there, then this and this get cancelled. So the resultant, maximum resultant is under root of R max and R max. 2 times R max and 2 times R min. So 2 times R max square plus R min square by 4. 1's 2's. The final answer is R max square plus R min square by 2. This is the perpendicular resultant. The perpendicular resultant, when the vectors are perpendicular, now what is the resultant in terms of maximum minimum? So maximum square plus minimum square by 2. Then substitute in that, you will get the answer there. Earlier we have taken the value 31 and 17. 31 square 961, 17 square 289. Now you add up, you will get 1250 by 2 625. Answer is 20. Right? Okay. Now a question was given in a previous entrance examination which reads like this. Two forces 1 Newton and P Newton, 1 Newton and P Newton have a resultant force of 1 Newton magnitude, and this resultant force is perpendicular to the earlier 1 Newton force. So the resultant is perpendicular to the first vector, first force. Then he is asking you to find the magnitude of P and the angle between the vectors. It was a very good question asked in previous entrance examination. Two forces 1 Newton, P Newton have a resultant of magnitude 1 Newton. And this resultant is perpendicular to the first force, earlier 1 Newton. Then find P and theta. Now let us estimate the question carefully. There are two forces 1 and P, but the resultant is again 1. Even though there is an extra force P, the resultant is 1. And the resultant is perpendicular to the first Newton force. So let the first vector be A bar and its magnitude is 1 Newton. The resultant itself is perpendicular to it. This is the resultant vector R. Magnitude is 1 Newton. You know the resultant is always the diagonal in between the two vectors. So the other vector lies in this direction. So the other vector is B bar whose magnitude is P. Completing the parallelogram, it is like this. Completing the parallelogram, it is this way. So first vector is A bar, magnitude of A bar is 1 Newton. The resultant is given as, the resultant is perpendicular to the first vector. So the resultant vector itself is 90, perpendicular to the first vector, A bar. But according to parallelogram law of vectors, the resultant always lies in between. It is the diagonal in between these two vectors. It is the diagonal passing the point of intersection of vectors. It lies in between the vectors. So the resultant itself is like this. So the second vector should be beyond that. Now the angle between the vectors, this is the angle between the vectors, theta. The angle between the vectors is theta. So let me denote it as theta like this. Now the angle is theta, which is obtuse. It is understood that the vectors make an obtuse angle, and this is the resultant vector there. You can do this problem by 3 methods. First we will go by the formula method, then I give you a simple shortcut formula. Even you can do it just by the diagram also. First we will go by the formula method. So given mod A is 1 and mod B is P and mod R is 1. Let me find the angle theta. Let me find a formula for the angle theta. So we know R square is equal to A square plus B square plus 2AB cos theta. So first let me substitute in this one, get a relation for it. So given R is 1 first. So we are doing this by the first method. There are 3 methods. Simple method also is there. So first let us do by all the method. Then you can choose whichever method you like, you can choose the way. So R is 1. A is also 1 square plus B is P square plus 2 into 1 into P cos theta. So 1 equal to 1 plus P square plus 2P cos theta. Well, this one gets cancelled there, right? So if I take P square this side, minus P square is 2P cos theta, right? One of the P get cancelled. So minus P is 2 cos theta. This is the first relation, please remember. First relation, please remember it. Then he has given that the resultant is making an angle 90 degree. The resultant is making an angle 90 degree with the perpendicular to the first vector. We know the resultant magnitude direction is tan alpha. It is B sin theta by A plus B cos theta. B sin theta by A plus B cos theta. Now given tan alpha is 90, the resultant is making perpendicular to the first vector. So therefore the resultant vector has angle 90 with this. Alpha is 90. So tan 90 is B. B is P sin theta by A plus B cos theta. It's 1 plus P cos theta. It's 1 plus P cos theta. So therefore tan 90, we know tan 90 is infinity. Tan 90 is undetermined. You cannot determine. Tan 90 is infinity. So infinity is P sin theta by 1 plus P cos theta. Infinity is something by 0. It's something by 0. So denominator has to be 0. So 1 plus P cos theta is 0. 1 plus P cos theta is equal to 0. So therefore P cos theta is minus 1. Or cos theta I can substitute as minus 1 by P. P cos theta is minus 1. So cos theta is minus 1 by P. This is equation 2. Now from these two you can find out. So first we have got the first vector. So first relation. The first relation as minus P is 2 into cos theta. In the second relation we got cos theta. From this cos theta I can write that as minus 1 by P. So substituting. So minus P is 2 times minus 1 by P. So minus minus cancel. So when I get P here, P square is 2. So P is root 2 Newton. Then substituting this in second equation, equation 2. So cos theta is equal to, substitute in the second equation. So root 2 cos theta is minus 1. or cos theta is minus 1 by root 2. You know, just now in the previous problem we have found the angle. If cos theta is 1 by root 2, you have to take it as cos 180 minus theta is 1 by root 2, and 1 by root 2, you know, it is cos 45. No, so 180 minus theta is 45. Theta you get it as 135 degrees. Right? So this way you can find out the magnitude and angle. Right? Thank you.